Finally, I'm going to show a different specification which ends up being equivalent to this model with the three interaction terms and the push versus pull effect and the three leg effects and the intercept. So it's 8 terms in total. There's an alternate specification where we simply add another variable called group, which is the combination of leg and type, push versus pull, and we make a model matrix using the formula 0 plus group. And the 0, adding 0 says we do not want an intercept in this model matrix. We just want to have the different groups compared. And the way that this model matrix looks is a 1 if you are pull L1, leg L1 in the first column. In the second column, it's push L1, then pull L2, etc. So it's basically you have a column of column with ones for each unique combination of these two variables, and there's 8 different combinations, so there's 8 different columns. We can fit a model using 0 plus group, the 0 plus group formula, and we'll save this to fit 4, and we can look at the coefficients. Now, these coefficients in themselves are not that interesting. We wouldn't want to necessarily compare these t-values because they're not comparisons of push versus pull or anything like in the previous model. These are simply going up from 0 to that group. So unless we want to say that the frictional coefficient is 0, which we know it's not, then this coefficient table is not that interesting. But we can use contrast to make our comparisons. So we're going to save the coefficients, and like before, I'll draw the arrows. In this case, they're fairly simple. So it looks like this. It's just an arrow from 0 up to the mean of each group. Because we have 8 coefficients and we have 8 groups, each arrowhead is aligned to the mean of each group. If we want to make contrasts, we can use the contrast function. So if we want to contrast push versus pull in the L2 group, we say group equals L2 push, group equals L2 pull, and we make the contrast. And this is a comparison that we might be interested in. And you can see it's just the 4th coefficient minus the 3rd coefficient, and it's also the same contrast that we had earlier here. So if we print this, we can see minus 6.18. This was the same as when we added the interaction term to the main push versus pull effect. So let's go back down. And we can also ask to contrast the differences of differences. Before, this was where we looked at the interaction terms if we were comparing against the reference level L1, or when we compared 2 interaction terms. In this case, it's a little more complicated. We have to actually do the math in our head. So suppose we want to compare the L3 push versus pull effect and the L2 push versus pull effect. So what we have to do is take the 6th coefficient, that's the yellow arrow, subtract the 5th coefficient, that's the green arrow, and then subtract the difference of the 4th coefficient and the 2nd coefficient. So you can see we have these 2 groups in parentheses. These are the differences. We want to take the difference of these differences. So what you can see is the terms that have minus in front of them is the 4th, the 5th. The terms that have pluses in front of them is the 6th and the 3rd, because we have a minus and a minus, which becomes a plus. So the contrast vector that we want to use to make this comparison has a plus in the 3rd element, a -1, a -1, and a +1. So we can make that contrast and perform it using the generalized linear hypothesis testing function, which is in library mult comp. We can extract the comparison and look at the estimate and its standard error, and now these are t-values and probabilities which we're interested in. So while we got the same, we were able to perform the same contrasts, we got the same t-values for those contrasts using this specification with the group. It depends on which is easier for you to think about. So adding interaction terms might be easier, and subtracting interaction terms than performing this kind of arithmetic in your head. You have to figure out which one gets the plus because it's been subtracted twice. But it is the same model.